Hi folks, so by now we have used Pythagoras theorem to find the hypotenuse of a triangle, which is the longest side, and we've also used it to find the shorter side as well. So now we're going to look at problems in context where we could be asked to find any side. So example 1, a ladder of length 4 metres is leaning against a wall. The top of the ladder reaches 2.5 metres up the wall. What is the distance between the wall and the bottom of the ladder? Now, for most of the other questions that we've done so far, we've had a diagram, and obviously here we don't have a diagram. So it's good to picture what's going on in your head and then somehow put that down onto paper. So you can see we've got the ladder here of length 4 metres. We've got the wall, and the 2.5 metres goes from the ground up to the top of the ladder. So that's the length of this part of the wall. And then finally, we're asked for the distance between the wall and the bottom of the ladder. So that then is, here I've just called it D for short. So we also here know that we've got a right angle triangle because we're assuming that buildings are built at 90 degrees to the ground, because otherwise they would be like the Leaning Tower of Pisa, and we wouldn't want that. So because we've got a right angle triangle, that means we can use Pythagoras' theorem. Now across from the right angle we have our ladder, which is 4 metres in length. So that means we've got 4 squared is equal to d squared plus 2.5 squared. Now we need d eventually to be the subject of our formula, so at the moment that's d squared we need, but there's a 2.5 squared being added onto that, so we need to subtract our 2.5 squared from both sides to give us d squared, that should be, is equal to 4 squared minus 2.5 squared. Then we can calculate that, and that gives us 9.75. Square rooting both sides gives us d being equal to 3.12. We're working in metres, and I've rounded my answer to 2 decimal places. So just now would be a good time to copy this down into your notes, and if you pause the video to do that, and we'll come back and we'll do a second example. So, example 2. The isosceles triangle shown has base of length 15 centimetres and perpendicular height of 9 centimetres. Find the perimeter of the triangle. Now, looking at what we need to do in the final part of the question is find the perimeter. So remember, perimeter is the total distance around the outside of a shape. We know one of those lengths, that's 15. We don't know the other two. We do know that those other two lengths are the same, so I suppose that's good. Now, we can't apply Pythagoras just now, because Pythagoras' theorem only works for right angle triangles. But can we create a right angle triangle? Now you'll notice here by creating the right angle triangle, the base is now split in half. So this length here and then this length here are the same because it's an isosceles triangle. So we now have a right angle triangle. And we know that the height is 9 centimetres. We actually know the base as well, so if the full base of the bigger triangle was 15, that means this must be 7.5 centimetres. And we need to find the hypotenuse here. So we've got a right angle triangle, like I said, so we can use Pythagoras. We can see that the hypotenuse is our question mark, so question mark squared is equal to 9 squared plus 7.5 squared. Putting that into your calculator, you get 137.25. Square rooting both sides gives us 11.72 centimetres, and I've rounded this to 2 decimal places, so I need to state that. Now, going back to the question, I'm not finished because it asked me to find the perimeter of the triangle. So the perimeter then, I now know that those two missing lengths are 11.72. So the perimeter must be 11.72 plus 15 plus 11.72, which in total gives me a perimeter of 38.44 centimetres. So again, folks, this is a slightly more complex question because we've got perimeter involved as well. So this is one you definitely need in your notes jotter because you might need it for the future. So if you copy that down just now, and when I post this on Teams, I'll put the appropriate pages up for you to try in your jotter as well.